Hello and welcome to this lecture video. In this video I'm going to talk about how to calculate internal rate of return with equal cash flows and with unequal cash flows. Recall from the prior lecture video that internal rate of return is an alternative to net present value. It does take into account the time value of money, and also that internal rate of return is the rate of return which equates the present value of cash inflows to the present value of cash outflows. Okay. We can interpret the internal rate of return as the rate of return that we're earning on the investment. And then what we can do is we can compare that rate of return, the internal rate of return, to our required rate of return that we have to earn on the investment. If our internal rate of return is higher, that's what we're earning on the investment. If that's higher than the required rate of return, it's an investment that we should take. If it's lower than the required rate of return, it's not an investment that we should take. So when we look over here in terms of our steps, I'm going to go on to the next page, and I'll say my step one, if I have net cash flows that are even, which implies an annuity, I can use the following formula. What I can do is I can take my initial outlay divided by my annuity amount, and what that gives me is my present value factor. And then what I can do is I can look in my table and I can find my present value factor right there. Okay? And then when I find the present value factor, I can look at the top of the column where the interest rates are. And when I find that interest rate, which is in the column headers, that is the internal rate of return at the top of the column. And then as I was saying earlier, if the IRR is greater than or equal to the required rate of return, we should accept the investment. If it's less than the required rate of return, we should reject the investment. So looking at this example, we have our initial outlay right over here. This is the way we're going to solve this problem. We're going to use this formula. We're going to take this initial outlay, which is our initial investment cost. That's what I'm saying right over here. Our initial investment cost divided by our annuity. So our investment cost, $84,753, right over here, and then divided by our annuity amount, which is $15,000. Okay? So I'm going to divide those two. $84,753 divided by my $15,000 equals my 5.6502. That is my present value factor. This is my present value of an annuity factor. And then what I can do is I can look in table B.3, which is the present value of annuity factor, at the back of your book to locate that factor and then look up at the top of the column, and that is the internal rate of return. So here I have my present value of an annuity table, which is table B.3. We know from this example that it says the investment costs $84,753, returns $15,000 a year for 10 years. So what I can do is look in my 10-year row right over here, 10 years. Okay? And I'm going to look for that factor of 5.6502. And when I find it right over here, 5.6502, I look up. This is my internal rate of return. This is my 12%. Why does this work? Remember, the internal rate of return is the rate of return that equates the present value of our cash inflows to the present value of our cash flows, and dividing the initial outlay by the annuity amount gives our factor. And if you multiply that factor of 5.6502 times 15,000, you would get the 84,753. So 12% is our internal rate of return. Okay? So that's the way we do that. We just look in our present value of annuity table, we find the factor, and then we look up at the top and we find this is the internal rate of return. So remember, we identified our internal rate of return is equal to our 12%. Okay? So the thing is, though, do we want to accept this project? Well, we're earning, remember, our internal rate of return equates the present value of our cash inflows to the present value of our cash outflows. but we can interpret the internal rate of return as the rate of return that we're earning on this investment. So we're earning 12%, but we want to earn 14%. We should reject this project because our internal rate of return is lower than the required. So we reject. If our internal rate of return was 18% and our required was 14%, then we should accept the project, but that's not the case here. Okay, so here's what I want you to do. I want you to do this problem, this Decker Company problem, and I want you to do this problem right over here on page 282, and then come back and we'll check it, okay? Okay, so looking at this problem right over here, our company can purchase a new machine at a cost of $104,320, and it saves $20,000 a year. So this is our annuity amount, okay? The machine has a 10-year life, and so what we do is we take the initial outlay divided by the annuity amount. This gives us our factor. Would you look up 10 years in the present value of an annuity table and you find this factor, and then you look up towards the top to find the column, you would have the internal rate of return equal to 14%. In this problem, we're not given the required rate of return, so we don't know whether we should accept it or reject it. This problem over here, it says our investment costs, $79,100, reduces operating costs by $14,000 per year for 10 years. Take the investment costs divided by our annuity amount of $14,000, gives us our 5.6502. We look up 5.650202 in our present value of an annuity table, and we find it on the 10-year row. Okay, it says that right over here. On the 10-year row, we look across at 10 years, find 5.6502. We look up towards the top, at the top of the column headers, and we see the internal rate of return equals 12%. Therefore, we reject it because the required rate of return is 18%, and we're only earning 12%, but we want to earn 18%. This quick check problem I did for you right over here. So it says an investment should be made if A, the internal rate of return is greater than or equal to the required rate of return. Now that was looking at internal rate of return with equal cash flows. With unequal cash flows, it's a little bit trickier, okay? And this is probably a little bit more realistic. So we can't just use that present value of an annuity table, okay, because that's assuming equal cash flows, but we have unequal cash flows. So I'm going to go over to the next page over here to explain our internal rate of return calculations using unequal cash flows. So if we look at this example, we're going to say a company is thinking about changing its production process, and that involves purchasing several pieces of equipment that cost $120,000. The changes to their production process are expected to give cost savings $49,500 in year 1, $45,000 in year 2, $35,000 in year 3, $22,000 in year 4, and $19,600 in year 5. Okay? This is not an annuity. Even though it's equally spaced out, it's not the same dollar amount. So this is not an annuity. So we can't do that trick that we did before to take the 120 divided by our annuity amount, because look, it's different amounts. It's not an annuity. So how do we solve this problem? What we do is we have to determine an initial guess at what the internal rate of return might be. And maybe a good initial guess would be to use the required rate of return. So let's say that our initial guess is 14%. Okay, so we initially guessed that our internal rate of return is 14%. So then what we do is we set up the table that we did before. We said we have time value 0. This is now. That's our $120,000 cash outflow. The factor is 1 because it's present value 120. And again, that's not a negative number. Let's just put it in parentheses because it's a cash outflow. Then we have our time period 1, $49,500. If you look in the present value of a single amount table, 14%, period 1, this would be your factor, 0.8772. And I want you to do that. I want you to verify that. Okay, so take a second, make sure you can find that. 14%, present value of a single amount table, 14%, period 1. This is our factor. Then what I do is I take my 49.5 times my 0.8772. This gives me my present value. Repeat it, 45,000. This is my factor at period 2 for 14%, 0.7695. There we go. Repeat that through period 5, and then we add up all of our cash inflows, subtract out our cash inflow, and then we get a positive net present value. Now, the question is 14%, is that our internal rate of return? No, it's not. How do I know it's not? Because this isn't a zero. Remember, our internal rate of return is the rate of return that equates the present value of the cash inflows to the present value of the cash outflows, which would mean when you find the internal rate of return, the net present value would be 0. This is not 0. So what we have to do is we have to guess again. And our next guess, because we have a positive net present value here, our next guess needs to be higher. So then when we look at 18%, you look in the present value of a single amount table, 18%, period 1, 0.8475 times the 49.5 gives us our 41, and then period 2, 18% present value single amount, so on and so forth, okay? We add up all these cash inflows, we subtract out our cash outflow, and then look, we have a negative net present value. So is 18% the internal rate of return? No, it's not, because this is not 0. Okay, this is not 0. So because we have a negative net present value, our next guess needs to be lower. So that's why we tried 16. Repeat the same thing. This is the present value of a single amount, 16% period 1, 0.8621 times our 49.5 gives us our present value. At the present value of our cash inflows, subtract our cash outflow, we get 26. This is pretty close, okay, especially since our tables are not in decimals, they're in whole numbers, okay? So we can assume that 16% is our internal rate of return because our net present value is pretty close to 0. In reality, if you really want to get very specific to figure out what the exact net present value, the exact internal rate of return is, it's slightly over 16%. Slightly over 16%. Okay, so moving on to page 284 of your course pack, here's a problem, and let's take a quick look at it, and I want you to pause the lecture video and then try this yourself, and then we'll check the answer together. So our Newport department store is thinking about developing a new e-commerce business. The company estimates that it will require initial outlay of $1,470,000. Other cash flows are as follows right over here. Okay, so we have year 1, cash outflow, year 2, cash inflow, year 3, cash inflow. Assuming the company limits its analysis to 5 years, estimate the internal rate of return. Should the company should it do this project if the required rate of return is 12%? And I'm telling you, your initial guess needs to be 6%, and then your next guess either needs to be 5% or it should be 7%. And the way I want you to solve this problem is just like on page 283. I want you to set up a table just like on page 283 where you have your time, your period, or your year, and then you have the cash flow, and then you have the factor, and then you have the present value, and then you determine the internal rate of return. Okay, so let's check to see how you did. So at 6%, you set up your table, you have your cash flow, and then you would say it's 6% period 1, present value is single amount, this is my factor. 700 then times 0.9434 gives me the present value. 221, the next period factor, present value single amount at 6%. Here's your cash inflows. You take your cash inflows minus your cash outflow, 71,757. You know that's not the internal rate of return because net present value is too high. It's not 0. Your next guess, I told you, would be either 5% or 7%, and your next guess has to be 7% because you have a large positive net present value here. Repeat the same process, and then what you have is a negative number, but this is pretty close to 0, so we can assume that the internal rate of return is 7%. Thank you.